September 12th, 2025. Astronomers witnessed the impossible. A massive object hurtles toward us from the depths of interstellar space. Its luminous tail extends 5 times wider than a full moon, eclipsing anything observed since Oumuamua's passage. Within mere hours, a second celestial wanderer is confirmed. Both entities race toward the sun for intimate encounters separated by only weeks, yet they emerge from completely opposite regions of the heavens. According to leading experts, the probability of such a synchronized cosmic arrival borders on the impossible. The official explanation? Twin comets. But mounting evidence suggests something far more deliberate, something engineered. A mysterious object of enormous scale now penetrates our solar system with an agenda that defies explanation. Is this an interstellar coincidence, or the opening gambit in a covert operation somehow triggered by humanity itself? The truth begins here. On September 12th, 2025, the SOHO spacecraft Swan instrument detected something that brought the astronomical community to a standstill. A brilliant new object blazed across the solar system, unmistakable in its intensity. Hours later, preliminary data revealed a staggering sight, a tail stretching nearly 2.5 degrees across the celestial canvas, roughly 5 times the diameter of a full moon. Such dimensions are virtually unprecedented for a newly discovered comet. Initial photometric analysis pegged its magnitude at 7.4, placing it within reach of modest backyard telescopes and even quality binoculars. Word spread like wildfire through the astronomical community. Amateur stargazers scrambled to verify what the satellites had captured. Just 2 days after the satellite alert, an observer in Australia documented a stunning photograph of the phenomenon, a streak of light so extensive it nearly exceeded the camera's frame. By September 13th, the International Astronomical Union made it official, designating the object C/2025 R2 and appending the tag Swan to honor the instrument responsible for its discovery. Within 1 weekend, both professional institutions and amateur enthusiasts had locked onto this enigma, exchanging images and brightness measurements across continents and hemispheres. The sheer magnitude and luminosity triggered immediate speculation. Most comets discovered in the modern era appear faint, typically requiring sophisticated telescopes for detection. Swan, however, shone brightly for anyone who knew where to direct their gaze, its tail slicing dramatically through the constellation Virgo and intensifying as it approached our star. The initial response transcended mere excitement. It bordered on disbelief. This was no ordinary icy remnant from the outer reaches. The measurements defied recent precedent. As observation reports accumulated, one reality crystallized. Swan physically dominated the inner solar system in a manner unseen since the days of Hale-Bopp, perhaps even longer. The amateur community, often first to detect brightness variations or anomalous behavior, immediately began debating what could possibly generate such an extensive and brilliant tail. For now, the object remained simply too large, too vivid, and too rapid to dismiss. As telescopes worldwide traced its trajectory, the question evolved from identifying what was to understanding why it had arrived now, and whether its timing represented merely the opening chapter of a far stranger mystery. C/2025 R2, officially designated Swan, isn't the sole newcomer commanding attention this October. Days before its discovery, another object, 3i/Atlas, was already inbound, approaching from an entirely different sector of space. Swan's trajectory traces back through Aquarius, while Atlas entered from the direction of Sagittarius. On a celestial map, these arrival vectors span more than a quarter of the observable sphere. Yet both objects are scheduled to reach their closest solar approach, perihelion, within the same 10-day window. For Swan, that critical moment arrives around October 20th at approximately 150 million kilometers from the Sun. For Atlas, perihelion occurs October 17th, just 3 days earlier, skimming past our star at roughly 203 million kilometers. This positions their closest solar points a mere 50 million kilometers apart, closer than Mars ever approaches Earth. This transcends overlapping dates. The geometry is extraordinary. Both objects follow steeply inclined orbits, with Swan's path tilted more than 60 degrees from the ecliptic plane, and Atlas nearly perpendicular to the planetary disk. Their approach angles differ so dramatically that the probability of both crossing the inner solar system simultaneously at such similar solar distances becomes vanishingly small. Astronomers tracking long-period comets and interstellar objects expect randomness, arrivals scattered throughout the calendar, perihelia distributed across months or years. Yet here, the two most luminous new objects of the decade converge on the Sun in near-perfect synchronization, each from a different corner of space. The timing introduces another troubling dimension. As both Swan and Atlas sweep to their closest solar approaches, Earth's telescopes effectively go blind. From October 8th through 18th, the Sun's overwhelming glare blocks direct observation, creating a blackout period covering the critical days when unusual behavior would be most visible. This means the moment of closest proximity, both to the Sun and to each other, unfolds beyond reach, with no means for ground-based observers to monitor events in real time. To have two such objects from widely separated origins reaching perihelion within days, at nearly identical solar distances, all during a period when the Sun itself shields them from scrutiny, this defies conventional expectations of random chance. In orbital dynamics terminology, this constitutes a corridor, a narrow window in space and time that both objects occupy together. Whether this represents coincidence, an underlying connection, or deliberate engineering remains unanswered. But the geometry alone gives even the most skeptical astronomer pause. 3I/Atlas first attracted attention not through brightness, but by breaking fundamental rules. Early spectroscopic analysis from the Atlas Spec Lab Group reported something alarming: a body dominated by nickel with virtually no detectable iron. This contradicts everything established about comets, which invariably display iron-nickel combinations in their vapor signatures. The claim proved so unexpected that several laboratories immediately demanded data verification, triggering a calibration controversy that spilled onto astronomy forums and sparked numerous independent reviews. The debate intensified with subsequent measurements. Instead of the classic water vapor signature, 3I/Atlas's coma expelled carbon dioxide at rates 5 times higher than water. The 4.3 micron CO2 spectral line dominated every reading, while H2O barely registered above background noise. Such ratios are rare but not impossible in comets originating from cold regions. What defied simple explanation was the tail's behavior. Observers tracking Atlas's motion detected a pattern: 3 distinct accelerations, each separated by approximately 2 weeks, each coinciding with dramatic changes in tail coloration. The first pulse occurred on July 29th, the second on August 14th. Photometric data revealed sudden brightness spikes, while the spectral slope shifted from reddish to nearly neutral, then reverted. These so-called delta-V pulses didn't exhibit the smooth characteristics of gradual solar heating. They emerged rapidly, then faded, as if the object had activated maneuvering thrusters. Peer reviewers challenged these findings, citing potential calibration drift or hidden systematic errors. But the Atlas Spec Lab team defended their analysis, demonstrating that the timing and magnitude of these pulses correlated across independent observatories, from the Barotracker network to Bill Gray's distributed telescope array. The data patterns didn't conform to typical outgassing behavior. The tail CO2 composition appeared to modulate in synchronization with each acceleration, a phenomenon some termed thrust mix modulation. What truly ignited widespread speculation was the energy calculation. If the observed accelerations were genuine, the implied power source within Atlas would need to generate approximately 10 gigawatts, equivalent to 10 large nuclear power plants operating simultaneously. This far exceeds any output capacity known for comet nuclei. The mainstream scientific position maintains that natural processes can account for most observations. However, the anomalies, particularly the nickel-only spectrum and the stepwise accelerations, have kept the engineered object hypothesis alive. For now, the Atlas anomaly file remains open, each new dataset fueling both skepticism and speculation in equal measure. C/2025R2, now simply called Swan, occupies a category entirely its own. The numbers tell an extraordinary story: a tail spanning 2.5 degrees, brightness rivaling the greatest comets of the past century, and a core that, if even the most conservative estimates prove accurate, could be generating 10,000 gigawatts of energy. That exceeds the total power output of Earth's entire electrical grid by a substantial margin. But scale alone isn't driving the conversation. It's the claims emerging from the astronomical community's fringes, assertions that Swan possesses armor, shielding, and power systems that challenge current understanding of physics. The speculation began with reflectance data. Standard comet nuclei scatter sunlight in predictable patterns, but Swan's core reflects light with a distinctive metallic signature. Some amateur spectroscopists argue this matches not simply nickel, but nickel-cobalt alloy, material selected on Earth specifically for strength and corrosion resistance. The term nickel-cobalt hull began circulating through online forums and late-night podcasts, fueled by the object's stubborn refusal to fragment or dim as it approaches the sun. Then came reports of an optical anomaly, a persistent silvery halo surrounding the nucleus, shifting in pattern and intensity. To some observers, it resembles a plasma envelope, a form of electromagnetic shield capable of deflecting solar wind and cosmic debris. This observation spawned a fortress nickname, unlike 3I/Atlas, which behaves more like a drone, quick, agile, and strangely efficient. Swan presents as a tank, slow, steady, and apparently invulnerable. The tail, already record-breaking in length, pulses with microcorrections that defy simple outgassing models. Photometric analysis reveals subtle rhythmic variations in tail direction, as though the object executes course adjustments using precision plasma bursts. Each pulse registers as a minor fluctuation in the brightness curve, and the pattern repeats with a regularity difficult to attribute to random surface eruptions. The orbital parameters add another startling dimension. Swan follows trajectory that returns it to the sun once every 22,554 years, a cycle spanning back to the last ice age. The implication is staggering. If this object is engineered, it's been following a predetermined course longer than human civilization has existed. It arrives now simultaneously with Atlas in the same solar corridor, during a window when Earth's telescopes are blinded by solar glare. The probability of all these factors combining through pure chance approaches zero. This confluence feeds a growing conviction that Swan isn't merely another comet. Its tremendous luminosity, evidence of advanced shielding, the potential armored hull, and the scale of its energy output make it the most formidable object to enter the inner solar system in living memory. Whether it a fortress, a probe, or something entirely beyond current understanding, Swan has forced astronomers to abandon old assumptions and open serious consideration of theories previously confined to science fiction. Every major anomaly documented for Swan and 3I/Atlas has shifted the discourse from what these objects are to what they might be doing. When two massive bodies, one on a 22,554-year return cycle, the other on a hyperbolic, possibly interstellar trajectory, arrive in near-perfect synchronization, the odds of pure coincidence collapse. The timing, the geometry, and the observation blackout have all spawned a wave of mission theories. One possibility appears almost routine by cosmic standards, a scheduled maintenance or refueling operation. In this scenario, the sun functions as a way station. Both objects could be engineered to harness solar energy or magnetic fields for recharging, data transfer, or systems diagnostics. The concept isn't far-fetched for deep space mission planning. On Earth, solar flybys are standard procedure for gravitational assists and energy augmentation. If these objects are probes, the sun represents a logical location for power replenishment or information exchange. Another theory carries darker implications. The close approach might constitute an intervention, a rendezvous to recover or neutralize a malfunctioning unit, or perhaps a confrontation between rival factions converging on a resource. The power levels estimated for each object, Atlas at approximately 10 gigawatts, Swan at a staggering 10,000, suggest energy reserves necessary for active maneuvering, not passive drifting. The stepwise accelerations and tail modulations in Atlas, combined with microthrust pulses in Swan, indicate a level of control consistent with mission profiles rather than random outgassing. There's also the audit chain scenario. Oumuamua in 2017, followed by Atlas and now Swan, could represent escalating responses to Earth's century of radio transmissions. Each new arrival would constitute a more sophisticated probe dispatched to monitor, collect data, or escalate contact protocols. In all three frameworks, the sun isn't merely a backdrop. It's the power node, the rendezvous coordinates, the beacon. The evidence doesn't resolve the debate, but it compels a critical question. If this is indeed a mission, what objective drives it? A 22,554-year orbital period transcends mere numbers on astronomical charts. It's a cycle reaching deep into the last ice age, when Earth bore little resemblance to our modern world. Around 20,000 BCE, glaciers blanketed much of the northern hemisphere, and climate shifts were reshaping the earliest foundations of human civilization. That same epoch left its signature in Greenland and Antarctic ice cores, where dust layers and subtle chemical variations hint at sudden, dramatic celestial events. Some researchers have noted these layers correlate with periods when bright, long-period comets could have swept through the inner solar system, leaving not just debris trails but stories that might have resonated through generations. At the center of this theory stands a location called Göbekli Tepe, a site in southeastern Turkey, constructed more than 11,000 years ago. Its massive stone pillars bear carvings of animals and abstract symbols, but among them are motifs that some interpret as depicting the paths of celestial objects, possibly comets. A small group of theorists argues these carvings record cycles far exceeding human lifespans, potentially even marking the return of something like Swan. The mainstream scientific view remains cautious. Archaeologists and astronomers alike warn that such connections are highly speculative, build on patterns that could equally represent coincidence. The debate grows heated, with critics emphasizing the absence of direct evidence linking these ancient monuments to specific astronomical cycles. Still, the timing proves difficult to dismiss. If Swan truly returns every 22,554 years, its previous passage through the inner solar system would have occurred precisely as Earth emerged from glacial dominance, at the moment when human culture was taking its first steps toward monument construction and celestial observation. Whether this represents coincidence or something more profound remains an open question, but it adds a layer of mythic resonance to an already extraordinary event. Ultimately, Swan's story transcends orbital mechanics and photometric data. It touches on the possibility that the sky's rarest visitors have always been interwoven with the narrative of our own origins. From October 8th through 18th, every major ground-based observatory faces a mandatory shutdown. Official schedules list this period as solar conjunction downtime, but behind closed doors, the restrictions extend far beyond routine protocol. Internal communications from U.S. Space Command and the European Space Agency direct teams to suspend all radar tracking and high-resolution imaging of both Swan and 3i/Atlas throughout this blackout. Proposals for alternative observation coverage are denied without explanation. Requests for raw data are quietly redirected or indefinitely delayed. Several telescope allocation reviewers, speaking confidentially, describe explicit directives to avoid public statements about either object until after perihelion. The result is enforced silence at precisely the moment when the two most unusual visitors in decades cross through solar glare, leaving only a narrow band of independent astronomers and amateur networks to bridge the information gap. When the blackout orders took effect, official channels went silent, but the amateur networks did not. Bill Gray, a veteran orbital tracker renowned for his open-source calculations, began mobilizing a distributed web of backyard astronomers and small observatories. His call resonated across public forums and encrypted communication channels. Keep your telescopes trained on the sky, document every anomaly, and share raw data before it can be suppressed. The Ibero Tracker Collective spanning Spain and Portugal began aggregating wide-field sensor feeds, while leaks from private astronomy groups suggested improvised plans to circumvent the blackout using radio telescopes and even repurpose weather satellites. With government agencies maintaining radio silence and major observatories locked down, the grassroots effort became the sole defense against a complete information vacuum. Anyone with a telescope, a radio dish, or access to open-source tracking software could participate. The blackout window wasn't merely a challenge. It became an invitation. If answers exist, you're now part of the search. When Swan and Atlas reemerge from behind the sun, the first signals might originate from someone's backyard, not a government laboratory. The facts are indisputable. Two anomalous objects have entered the inner solar system together, defying statistical probability and raising questions no official agency has addressed. The truth, whatever it may be, awaits on the other side of the blackout. At 3:47 Universal Time Coordinated on October 17th, Bill Gray's distributed network picked up the first signal. A radio telescope in rural Portugal, operating on a shoestring budget and amateur dedication, detected something emerging from the solar corona. Atlas had reached perihelion. But instead of the expected brightening as it swung around the sun, the readings showed something impossible. The object had split. Not fragmented, split. 3 distinct signatures, each radiating identical power levels, each on precisely calculated trajectories. The separation wasn't chaotic, like a comet breaking apart under solar stress. It was geometric, mathematical. Within minutes, observers across the network confirmed it. Atlas had deployed. The mainstream channels remained silent. No NASA statement. No ESA press conference. But the underground forums exploded with data. Amateur spectroscopists reported that all 3 Atlas fragments were accelerating, not away from the sun as expected, but toward specific coordinates in the inner solar system. One fragment angled toward Mars' orbit. Another adjusted course for the asteroid belt. The third was heading directly toward Earth's Lagrange point L4, a gravitationally stable zone ahead of our planet's orbit. Then Bill Gray posted a single line that changed everything. Swan just altered course. Confirmed by 5 independent stations. This is not orbital mechanics. This is navigation. October 20th arrived with Swan's perihelion, but the anticipated spectacle never materialized to the public. What the amateur network witnessed, however, would fuel debates for generations. As Swan rounded the sun at 150 million kilometers, its massive tail, already record-breaking, suddenly collapsed inward, not dissipated, not swept away by solar wind, but retracted, as if pulled by an invisible force. Within 6 hours, the object that had dominated telescopes for weeks shrank to a pinpoint of light with an energy signature that made Atlas look like a flashlight. Maria Castellanos, operating a modified radio array in Valencia, was the first to catch what happened next. Her voice, recorded in a hastily uploaded video that would go viral before being scrubbed from major platforms, trembled with awe. It's not a comet. It never was. Swan just opened. There are structures. I'm seeing right-angle geometry. There are structures inside. The amateur network's combined data painted an impossible picture. Swan's outer shell, if that's what the comet appearance had been, peeled back like flower petals, revealing a core that reflected radar and patterns no natural object could produce. The fortress, nicknamed, suddenly seemed less like speculation and more like understatement. But the most startling observation came from the Ibero Collective's thermal imaging array. As Swan completed its transformation, it emitted a focused beam, not of light, but of modulated electromagnetic radiation, aimed precisely at the Atlas fragment approaching Earth's L4 point. The signal lasted exactly 22.554 seconds. The correlation to Swan's orbital period in millennia was immediately noted. It couldn't be coincidence. At 14:23 Universal Time Coordinated on October 21st, every major space agency simultaneously released identical statements. The wording was careful, clinical, and utterly inadequate to the moment. Recent observations of cometary object C/2025 R2 and 3I/Atlas have revealed unusual but not unprecedented behavior consistent with volatile outgassing and fragmentation events. The public is assured that no threat to Earth exists. Further study is ongoing. The statement's very precision betrayed its purpose: to say nothing while appearing to say something. But the amateur networks weren't silenced so easily. Within hours, leaked documents began surfacing on encrypted servers. Communications between space command facilities, evacuation protocols for the International Space Station, urgent requisitions for deep space tracking arrays that had been mothballed for decades. Most explosive was a fragment of an internal ESA memo, date-stamped October 18th. Preliminary linguistic analysis of the Swan-Atlas exchange suggests mathematical encoding consistent with navigation protocols. The probability that this represents natural phenomena has been revised to less than 0.001%. Recommend immediate implementation of Guardian contingency procedures. Guardian. No one in the public sphere had heard the term before, but its implications were clear. Someone, somewhere, had been preparing for this possibility. They had protocols. They had contingencies. They had been waiting. Dr. Sarah Chun, a radio astronomer who had risked her career to join the underground network, gave voice to what many were thinking in a late-night broadcast that reached millions before it was taken down. For 70 years, we've been screaming into the cosmos. Here we are. We exist. We never seriously considered that someone might actually be listening. Or worse, that someone might have been watching long before we ever sent our first signal. The Atlas fragment designated A3 by the amateur network settled into Earth's L4 point on October 23rd. Its position was gravitationally stable. It would remain there indefinitely without active maneuvering, traveling in lockstep with Earth orbit but 60 degrees ahead of our planet. Dr. Harold Zimmerman, a veteran planetologist with 40 years at NASA before his retirement, broke his silence in a video statement that his family later confirmed was recorded just hours before his home internet was coincidentally severed. What's sitting at L4 isn't a comet fragment. The spectroscopic data, the real data, not the sanitized versions being released, shows a nickel-titanium composite shell surrounding what can only be described as a power plant. The energy signature matches theoretical models for contained fusion reactions. This object is producing electricity at industrial scales. It has solar panels deployed. It's been there for 4 days, and it's doing something, building something, or waiting for something. The implications hung in the air like a hell breath. An object of unknown origin, clearly manufactured, sitting in one of the most stable positions relative to Earth, powered up and operational. Not approaching, not threatening, just there, watching. Independent calculations suggested that from L4, a sufficiently advanced sensor array could monitor virtually everything happening on Earth's surface. Communications, industrial activity, the electromagnetic signature of human civilization. And unlike a satellite in Earth orbit, there was no legal framework for addressing it. L4 was beyond any national boundary, beyond the moon, beyond any established jurisdiction. While attention fixated on the L4 mystery, Swan completed its solar flyby and began its outbound journey. But something had changed. The amateur network's tracking data showed that Swan's post-perihelion trajectory didn't match its inbound path. The deviation was subtle, mere fractions of a degree, but over astronomical distances, it meant everything. Bill Gray ran the calculations 3 times before posting his findings. Swan's new course will bring it back in approximately 22,554 years, but not to the same point in Earth's orbit. When it returns, we'll be on the opposite side of the Sun. Either this is the most unlikely orbital perturbation in recorded history, or Swan just scheduled its next appointment for when humanity's descendants will be in a specific location. The message was clear. Swan wasn't just passing through. It was planning. And whatever had transpired during its brief, censored perihelion passage had set something in motion, a countdown measured not in days or years, but in epochs. On November 1st, 2025, at precisely midnight UTC, the fragment at L4 transmitted. The signal lasted 47 seconds and repeated every 12 hours for 3 days before ceasing entirely. It wasn't directed at Earth, at least not at the surface. The beam was aimed upward, away from the ecliptic plane, toward a point in space that held no remarkable features. No star, no nebula, just empty darkness between the constellations. Amateur operators worldwide recorded it. The signal structure was unmistakable, a mathematical sequence. Prime numbers initially, then increasingly complex patterns that linguists, mathematicians, and cryptographers would spend years attempting to decode. But the message wasn't in the content alone. It was in the act itself. Whatever sat at L4 was calling home, or calling forward, or calling someone else. Government agencies adapted quickly. The narrative shifted from denial to contextualization. Yes, anomalous objects had passed through the inner solar system. Yes, their behavior was unusual. Yes, there was an inert fragment at L4. But no, There was no immediate threat. No, first contact protocols had not been triggered. No, the public should not panic. What they didn't say was more telling. No explanation for the Swan Atlas signal exchange. No comment on the L4 transmissions. No acknowledgement of the mounting evidence that humanity had just witnessed the most significant event in its history while being actively prevented from understanding it. The amateur networks continued their vigil, but slowly, methodically, they found themselves marginalized. Algorithms changed. Posts disappeared. Forums were flooded with disinformation so thick that real data became indistinguishable from fabrication. Bill Gray's website was hit with distributed denial-of-service attacks that continued for months. Independent researchers found funding mysteriously withdrawn, credentials questioned, careers stalled. The message was clear. The blackout hadn't ended with perihelion. It had simply changed form. As 2025 drew to a close, the object at L4 remained, silent now, waiting. Its solar panels gleamed in telescope images, proof of its presence, proof that it was operational, proof that it was real. But what was doing, what was building or monitoring or preparing, remained unknown. Swan continued its outbound journey, its light dimming as it retreated toward the outer solar system and beyond. In 22,554 years, it would return. But in the here and now, it had left something behind. A marker, a sentinel, a promise, or a warning. No one could say for certain. Dr. Chen's words echoed to the underground networks, shared in whispers and encrypted messages. We've been asking, are we alone, for generations. But we've been asking the wrong question. We should have been asking who's been here all along, and what happens now that we've finally been noticed? In Beijing, Washington, Moscow, and Brussels, emergency meetings continue behind closed doors. New telescopes were commissioned, funded by black budget allocations that would never appear in public records. Deep space tracking networks expanded quietly. Protocols were written, rewritten, and sealed in vaults alongside other scenarios humanity preferred to pretend were impossible. On a clear night in December 2025, Maria Castellanos stood beside her radio array in Valencia, watching the stars. Somewhere up there, invisible to the naked eye but unmistakable in her data feeds, the L4 object maintained its vigil. Swan's fading light marked the edge of the solar system, a farewell from something that had deliberately chosen to arrive now, in this moment, after 22 millennia of silence. She thought about Göbekli Tepe and its ancient stones. She thought about the ice cores with their mysterious layers from the last time Swan had visited. She thought about all the myths and stories humanity had told itself about visitors from the stars, and how those stories might not have been myths at all. Her equipment beeped softly, recording, documenting, preserving. The truth, whatever it was, wouldn't stay hidden forever. The blackout could suppress information, but it couldn't erase what had happened. Thousands of amateur astronomers worldwide had seen. They had recorded. They had shared. The facts remained indisputable. Two anomalous objects had entered the inner solar system together. One had deployed. One had transformed. Both had demonstrated technology beyond current human capability. And now, something waited at L4, watching humanity with patient, inscrutable attention. The question was no longer whether we were alone. The question was what came next. And somewhere in the darkness of space, moving on trajectories calculated with precision beyond chance, other objects might already be on their way. Swan had taken 22,554 years to return, but a 3 signal had taken only seconds to propagate outward, carrying news that would reach the nearest stars in just a few years. The cosmic silence that had surrounded humanity for its entire existence had been broken, not by us, but by someone that had been watching long before we learned to look up at the stars and wonder. The waiting had begun, and this time we weren't waiting alone.